I was looking around on eBay for a kit to build, and I came across this power supply kit, which I proceeded to buy on eBay for $85. This is a page from Ali where it's available for $70. So I could have saved some money. This is a horribly described kit. They do show a power transformer, which I believe to be 220 volts, and what appears to be a line cord. The description of this thing says it's a 19 to 24 volt AC power, which doesn't make sense. And they sell it as a 0 to 30 volt 5 amp adjustable power supply. It's got 4 control knobs: big knob, little knob, big knob, and some output jacks. And you can very faintly see that there's a plastic enclosure around the thing. It doesn't show up well in the description. You can just faintly see the outline. And so I ordered one. And this is what I got. It's a fairly heavy box, delivered from China. No other markings on it. Take this to be the enclosure and the circuit board. One of the Chinese volt ammeters. Chinese power transformer. 220 volts input, 50 hertz, an output of 20 volts at 30 VA. Well, that's an amp and a half. There's no way in hell this could provide 5 amps. It's a nice enough little transformer. It's a real shame they didn't split the primary, which would allow 110 or 220 connection. And then we have this package. Got a heat sink with 2 crookedly drilled holes in it, and they're tapped. A fan, 12 volts at a tenth of an amp. And 2 packages. This one's full of components, nuts, And this one's full of knobs, potentiometers, terminals. One. I'm going to have to open it. I'll probably lose parts now. We've got two rather large banana jacks. That is with a red and a black one. Then we have a separate red one. 4 potentiometers, 2 10K potentiometers and 2 1K potentiometers. 2 heat sinks, identical. 4 knobs. Okay, that's everything in that package. Then I'll take out the circuit board. So with the circuit board comes the enclosure, I hope. There's a piece. And the circuit board. There is no power cord. These are sort of they appear to be coated with something. It's a little bit soft. These two are identical. That means these the top and bottom. The bottom and top are slightly different. So this is going to form a box. At its widest spot, it's about 4 5/8. A little more than 7 inches long. The front, I can tell it's the front because it has the meter. There's a blue line on it as well. I don't believe this is a tear-off coating. Maybe it is. Alright, so that's what we got. Blue line here too. Purple line. I don't know what that means. The back has an opening for a power cord. The heat sink and fan are external. And this is the fan power going inside the case. So maybe I can put a bigger transformer in. Now this little transformer is shown sitting like this. I'm going to see if I can put a bigger transformer in here. And 110 volt primary. The first thing I tried to do was sort out where the hardware goes. So the top and the bottom each use 6 screws, and they're the longest screws here. And they also use 6 nuts apiece. The board does mount upon standoffs, which are secured by screws. Now, I know I have these in upside down, I'm just storing them there. But the standoffs mount with screws that were supplied in the kit. such that the geometry works out like this. This heat sink apparently just ends up floating in midair, supported mostly by the leads through the board. 4 of these nuts, one each on top of these standoffs. I did not have a screw long enough to go through here in the kit, so I supplied my own. And there were no screws left over, so that screw must have been omitted. These 2 devices have insulators and insulator bushing screws. They were all in the kit. This device has an insulated bushing. As I say, the screw was missing. This was all in the kit. So that means I have these 4 nuts accounted for. They go on here. That leaves me with these that I have no idea where they go. Perhaps as this comes together, I'll find out. There are no screws for fastening the transformer. They were not included in the kit. So this is the PCB for this power supply. I have managed to create a schematic. I can't find any hint of this board on the web at all. Now, it's very, very much schematic-wise like the popular 30-volt 3-amp power supply that sells for under $10, the kit, that is, sells for under $10. Now, the 30-volt 3-amp has 3 of these TL081s, and it does not have a TL431 or any other voltage reference. That means that this power supply will suffer the same problems as the 30-volt 3-amp Chinese kit. That is, it has a system negative, and then it has a minus 5-volt reference. The integrated circuits are supplied from the positive rail and the minus rail. So whatever voltage you've got between power negative and power positive, you have to add 5 volts to it. Now these things are good for 40 volts, but it's pretty easy for this rail here to go above 35 volts. A lot of power transformers that are advertised as having 24-volt outputs only have that output at full load. They may have 28 or 29 volts at no load. The other problem is one of metering. If you use analog meters, you're fine. Voltmeter and ammeter right here satisfies the metering. But the negative output is its own rail. It's separated from power negative by this current measuring resistor. So to measure the voltage with the combination Chinese meter, that is the little 2-line amp voltmeter that comes with the kit, it's very difficult to do. I guess you could try to power it here Anyway, the faults of this circuit, or at least the one like it, are very well talked about on the web. I've also got a 2-page bill of materials for the components on the board, not the hardware that comes in the kit. And I've done a board layout. Now all of this information, as well as some supporting documents, will be in my subdirectory. There'll be a link below the video to it. But these are ongoing. You can see I'm still checking and making some additions and corrections as I go. I'm going to go ahead and start populating this board. It's interesting to look here at this corner once. You see it's an XDT-linear, 0 to 30, 0 to 5. The logo is XTD, not XDT. Of course, this writing, which is in English, is apparently here in Chinese. So maybe XDT is XTD in Chinese, who knows? There are no other markings. Constant current, I assume that's that in Chinese. Screw in the corners. There's a little number here. I believe that to be the board maker's identification number. Something for him to keep track of. But look at this. It indicates 4 screws here going into the bottom of the heatsink. So I'm going to go ahead and populate this board. I don't think there's any reason for you to watch it on video. There's lots of board populating videos. So the next time you see this, it should be populated. So I'm down to these parts. Well, these 2 integrated circuits, I put sockets in that did not come with the kits. In order to accommodate these LEDs, I put sockets here. This grommet is supposed to go in the back of the case. Actually, it's supposed to go right here. Or here, you can reverse this. These 2 resistors and capacitor are left over. This little red washer's left over. Let me show you what I did with the heat sink. Remember I said there was little screw indicators here? Well, I placed these components on the heat sink. Now remember, the heat sink had pre-drilled and tapped holes. I found out which of these 3 spaces, well, I found out which spaces accommodated clearly these back row of holes. And sure enough, 3 of them did. You can see they're actually spread apart. I ran, these are 6mm standoffs with threaded on one end and an M3 tapped hole on the other end. 6mm spacer. I just ran that into this open space. I distorted the fins a little bit. And I found 3 of them, not 4 as shown here. That seemed to fill the bill. And it allows me to put the back on and there we go. This is the same spacer that is used to elevate the board. So it's a male by a female. Now, I said this pot was not included in the kit. This is the best one I can come up with for my scrap box, so I think I'll just maybe order an assortment of this style. On the silk screen, it would indicate that this socket is installed the opposite way. The silk screen on the board is marked like this, which would indicate this is rotated. But you see, this one over here is marked positive. The fan they gave, when I plug it in, the positive is located correctly. If I had located the socket as indicated on the silk screen, the polarity would be reversed for the fan. Here's a thermistor bead. I've put shrink wrap tubing on each leg. This needs to be fastened, thermally fastened to the heatsink. I may bend it and try to get it up between one of these fins, or I may just somehow press it against here. I'm not sure how I'm going to do that yet. Here are these devices. These are the heat sinks that they came with. This one should mount this way. Well, you see, it will not mount that way. This one was intended to mount this way, which certainly leaves it flapping in the breeze. I'm not really comfortable with this. So I'm going to go through my heat sinks and see if there's anything I can... Well, I don't know what I'm going to do there. The other thing I did was put sockets here for power in, here for power out. They just fell in the holes. Put these sockets in for the potentiometers. This board was laid out as if the potentiometers were mounted to the board, and the board then would have to be on the front of the panel so that the shaft on the knob could reach through. This layout puts the board at the back of the panel with the potentiometers mounted on the front. It's going to be a lot of wiring. That's the same reason I put the sockets on for the LEDs. They're mounted on the front panel. Now I did have to drill out these 6 holes. If you're interested, I used the number 56 drill to make 6 holes. There we go. This is a 12-volt fan. So I ordered some 24-volt fans. The board designer expects you to use a 24-volt fan. There's an increasing number of reasons why this is not a good kit. But I will forge ahead and see what's going to happen.